if we took Susanne, a couple of timelines of Susanne, different alternative universes of Susanne, which version do you think she contributes the most to science? Is it the Institute for Advanced Study, Susanne? Is it current Susanne? Is it extremely burdened by administrative stuff, Susanne?
That was...
You don't know.
I love administration. No, I don't.
It's been 95% of my time.
No, I mean, okay. So, obviously, if I talk,
okay,
if I talk from a
one.
personal point of view, I definitely thrive best in an environment where I am allowed to do whatever I want. Then I actually went to Spain for 10 years. Amazing. And I did theater in Spain for 10 years. So touring a lot, working in different companies. I also had my own. I also directed some pieces. And then at some point, I had a child. I got divorced, and then I also felt like, do I want to do theater for the rest of my life? I feel I'm intellectually I'm missing something.
Interesting.
And then I decided for studying math, and I was always very, very good at math in high school and in primary school, and the problem is, it was not like, now I want to study math in order to become something in math. It was more like a hobby. Ooh. Now, that is that you have these, it's called stochastic resonance, but you have effects where you have a deterministic model, and that deterministic model can actually not reveal the information that is underlying it. Okay, it becomes a little cryptic now. Then you add noise to it, so randomness. Poof, the pattern appears. So that means that if you have a system that is noisy, you get more information out than you have without noise. Okay?
Not okay.
And it's called, yeah.
Not okay.
But I can the simple.
My guest today used to be a professional actress in Spain before she decided to throw everything away and pursue a career in math. Professor Susanne Ditlevsen is an incredible example of someone who I think does what a lot of people consider to be impossible, which is, can you completely revamp your life in your early 30s and become world leading in a topic as highly technical as mathematics? Today, Professor Susanne Ditlevsen is a professor of statistics at the University of Copenhagen. She is the president of the Royal Danish Academy of Sciences, and her work spans everything from COVID modeling to neuroscience applications to, I think, the diving behavior of narwhals. The thing that stood out to me the most about Susanne, and I like to have this mental picture when I meet people, that everybody has a battery of some capacity inside of them. And some have smaller batteries, some have AAA batteries. In meeting Susanne at the University of Copenhagen, from the first moment to the last, it's as if she doesn't have a battery. She has a freaking nuclear generator just beaming inside of her. Susanne is incredible. She's intense. She gives you the feeling that she can do absolutely anything. It's a very inspirational figure to be close to. And it feels like if I ask her to go and play in the NBA, she might just figure it out. Susanne is amazing. So really enjoy this conversation with the incredible Susanne Ditlevsen. I have a little bit of anxiety that I don't know how to get rid of. And so I guess the favor is I would like to see if you could help me figure out how to deal with that anxiety. So what is the context of the anxiety? It is tied to probability. Mm-hmm. When I try to take seriously what probability is, it feels like I end up on a road that is full of anxiety, no matter which road I end up taking. And I'll tell you what I mean. If I take a classic case of probability, like, I toss a coin, and there's a 50-50 chance. And if I really try to take that seriously, I go, no, that seems odd. Like, what does that even mean? Because I go, if I toss a coin, and I know the exact dimensions of the coin, and I know how much force is exerted upon the coin as I release it from my thumb, and the wind resistance as it, goes through the air. And if I try to think of all of those things and have access to all of these measurements, then I go, well, really, there's no probability here. Like, it's determined. It must be. Like, I know exactly what the coin is going to be. The outcome is determined. So if I try to look at it from that lens, I go, okay, that means in this narrow example, probability is it's an approximation. It's because I don't know all of these things about the coin. So I try to say there's a lot of stuff that I don't know, and considering that, I'll try to make a judgment. But then I say, okay, well, how far can I stretch this idea of if I just have the data points, all of the variables, does it mean that the outcome is determined already? Because I go, okay, does that mean if somebody's in traffic and I'm looking at somebody right now and I know all of the perfect measurements and the distance from their foot to the speeder and the speed of the reflexes that they have, would I be able to say whether or not they're going to crash? Because isn't it just a question of if I know all of the variables, then I know whatever the output is going to be. And then I go, okay, well, does this end or does this go if I know about all of the particles in the entire universe and their position? Could I essentially just hit the tape and then the universe plays out because I can predict everything, because really everything is completely predetermined? Well, that's insane. But then I go, but the alternative is also crazy, because the alternative means it's not predetermined. But then I go, what causes behavior then? What causes an output to happen? Then seems almost even more crazy to me. It's like both of the paths here are very, I'll say scary, but anxiety filled. Either it's random, which I don't know what really means, or it's determined. But then I go, well, how far does that stretch? Yeah, I don't know what to do about this. I don't know how to deal with it. So I guess the first question, if you can even call it that, is what the hell is probability? Like, what is this? I'll kind of leave a big open question mark for you to attack.
Okay, so that was a very philosophical opening, and it's a very philosophical question. And I'm not a specialist in the philosophical implications here, but I'll make different answers to that. My approach in my work is quite pragmatic, in the sense of probability being a tool for giving you answers of certain questions. The philosophical question of whether uncertainty or probability exist in the real world, I'm quite sure if you talk quantum mechanics, you will find genuine probabilities, and you better talk with people that are specialists in that about that. Now, if you talk about things that can happen, or things whether one thing or the other will happen, there's no doubt that the physical laws in the situation where you know everything can tell you the outcome of a die, that if you throw dices. So but that is kind of irrelevant in the real world, because you would never know. You would never be able to measure all those things. So you do need the probability as a model for such a thing. Then you might have probabilities. Say, say you do I'm also a statistician. So say you do statistics, and you want to know the probability of whether you have cancer, given that you took a test, some kind of diagnostic test that was positive. We could also say during Corona, and you took a Corona test, and the test was positive. That doesn't mean that you necessarily have the Corona, so there will be a probability of whether you have Corona or not. Of course, you do either have or don't have Corona, but you don't know it. So in that sense, you need the probability to make a model of these probabilities. And when I calculate the probability of whether I have the disease or not, given that I was positive in a test, will depend on how frequent the disease is, and a lot of how good the test is, and all these things. So in a certain sense, you could say that probability is a very, very good tool or model for when things are uncertain. You can think about it in another example. If you play poker, there are two players. Let's say two players with poker. One player know the hand that he or she is having. So there's no uncertainty there, no probability. But the other one doesn't. And it makes perfectly sense for the other one to think about the probability of what that other player could have on his or her hand. That doesn't. It doesn't mean that there needs to be something inherently probabilistic in that. It is simply from a point of view of what is the information I have, then what is the probability? If I gain more information, the probabilities will change. So and that is exactly what I work with. When you're a statistician, you collect data, and then you might want to infer something about the real world. And when you want to infer something about the real world, it's usually something that you cannot observe directly. And if you cannot observe it directly, so there might be a truth out there. The truth is there, and it's something, but we don't know it. We cannot measure it directly. So we take some measurements of something that is hopefully indirectly saying something about what we want to know. And then from that data we have collected, we try to infer this, let's say, scientific question or just question that we have about the real world. And then I can calculate, given some models, given some assumptions, given what I know about the world, then I can calculate probabilities of whatever I want to know about the world. And that is something. Now I collect more data. And it's not like I changed the reality. I did not change the real world. I changed my knowledge about the real world. Then my probabilities will change. So say I want to estimate the value of some variable or some parameter, whatever. I want to know about that value. Then I could just collect more and more data. And every time I collect more data, every time I learn more, and I can, and my probabilities change. So in that sense, I think about probabilities in a very pragmatic way, as a tool to learn about the world or understand about the world.
That's incredible. Yeah, that's incredible. Okay, so I guess the first one was whether or not we can say if randomness is there. That seems to be, you're right, the physicist needs to tell us about quantum mechanics, and maybe the philosopher needs to tell us whatever he thinks. But the reality dictates that you wouldn't be able to get access to those measurements anyways. You cannot get to infinitely precise measurements about anything. So what the hell do you then do? Do you just accept that we can't know? Or in this case, you build a tool that allows you to, with whatever information you've been able to gather, still infer something about whatever the outcome is, even though you don't have the full measurements to the outcome.
Yeah, but often you don't need to know it exactly, but you need to know the ballpark of the measurement, or maybe I want the value of something, and the real value is 7.32467910. Not 10. Sorry. Okay, not 10. 10.
Yeah.
Okay, but that is maybe irrelevant for the problem that you have at hand. It's enough to know it's around 7. Maybe.
Yeah.
It depends on what it should be. So if you work in the medical sciences, you might want to know what is, which is already a weird kind of question. What is the probability that I get breast cancer before I turn 50, boom.
Yeah.
Then, if somebody asked me that question, I would ask, but where do you live? How do you live? Are you male or female? And the probability of getting breast cancer is much, much higher if you're female than you're male, but males do get breast cancer.
Oh, no.
And if you live in certain parts of the world, the probability will be larger. If you live a life that you do this, and that, it will also change. So all the time, I'm narrowing down the more information I can get. And there you have different types of, let's say, probabilities. Now you talk about probabilities, because one thing is, what is the probability out there? Could be something. And that has to do with the variability in the real world. So, for example, if you talk about breast cancer again, we are different. We are two different. So two different people will, of course, vary simply because there are variability. But then you also have that you try to observe it through data. And then you get uncertainties related to the data collection and to the analysis. So you have the variability that's out there because it's there, because life is variable. And then you have the uncertainty from trying to infer about the real world.
That's amazing. Yeah, that's super rich. Like you have to make the split that there's some kind of out there variability that will exist. And then our approach in trying to collect information about it, we have to be critical of the information that we collect. And are there any potential errors hiding there that will also introduce some kind of additional uncertainty? It's like doubling up of uncertainty. That's amazing. You also said, which I think was beautifully put, that we can collect information to figure out, whatever the outcome, the probability of a certain outcome is about the real world. And then the more information we collect, ideally, the better we become at saying something. But it isn't because reality changed. It's not because we changed the actual thing. We just managed to give us more stuff that can tell us about it.
Of course, sometimes doing measurements does affect what you're doing. But let's say that you can observe it without.
That's an amazing idea.
So the difference is what we know and what is the real truth out there.
I love that point as well. I think it's super funky to think about the impact of the observer on that which is measured. If he's almost a part of the system, if he disrupts the thing that is being measured while measuring it is super weird as well. Even just like...
but it's quite normal because... actually, you can think. You don't even have to think about weird physics and philosophical things. You can just think about if you want to. I don't want to stay too much in the medical world, but now I take another.
So if you be a medical podcaster,
if you want to measure some kind of disease, you might be invasive in order to.
Great point.
And in the moment you are invasive, and just think about that, you want the police to measure how traffic is going. I am sure that the fact that the police is out there will affect how the traffic is running. So just the fact that there's a police car will change how people drive.
Yeah, that's good. Yeah, I love that. That's good. You're right. It's not as esoteric as it maybe seemed at the outset, at least at the way that I kind of thought about it initially. It was like, oh, this is a crazy... I thought it from like a Immanuel Kant perspective of going... phenomenologically, like we're part of the world. So but you're right. It's easier to go, there's a cop car, I'm probably going to drive there. I love that. That's so good. If I take a step back and I go, I'm trying to make a prediction about whatever. I'm trying to say, I wonder if this given outcome is going to occur. And then and I have no idea. I don't know. And then Susanne comes and she says, you know what, actually, this is the probability distribution. I'll go, what the hell? How can you do that? And she goes, well, these are the pieces of things that I can see, I can observe, and I can make that judgment. My immediate question would be, how the hell do you know? Like, why is it this and not that? Like, how do you actually pick the data points that will have an influence? Is that like you're trying to come up with some kind of causal definition? You're trying to like explanatory-wise go, like, these things seem to be from first principles connected. Is it you're just trying to observe patterns in data, and from there go, it seems there's clearly a correlation. So that must be the...
But you can do all of those things. It depends. It depends very much on the scientific question. I love the concept of scientific question. So the first thing you have to do before deciding anything about what data you want to collect and what analysis you want to do, the first thing you have to be really clear about is, what is your scientific question? Because you might have a scientific question that is causal in its essence. So, for example, I want to understand how the body works.
Can we actually just pause and define what is a scientific question versus, let's say, a normal question? What makes it particularly scientific? Is it that can be...
Okay.
Yeah, so I need to open up that one as well. But...
Yeah. Okay, so it's not so important whether you put the word scientific. It's more well defined. So here I think as a mathematician. So define to me exactly what you want to know. In that sense, it doesn't have, I mean, I just heard a talk yesterday, and in this talk...
Good timing.
Yeah, I heard a talk yesterday, and this was about what is a scientist?
Oh, wow.
And it was actually coming up with a question of what age should a scientist have, and then the speaker had some examples of a child doing really basic science and making some actually papers that other scientists did not recognize that it was a 15 or 16-year-old that had done them. But anyway, so the thing is that you might have a scientific approach whether you're a scientist or not. So it's kind of having a question that is well defined, and then you go. I would say there's a scientific method in the sense that you go about the problem looking at the different angles that it can have. Just to come back to what I said, you can have a question that is causal in its nature. That might be you want to understand how something works. How are the interaction? What thing makes another one change? And that is a very specific type of scientific question. But you might also have another scientific question, which is, I want to predict the weather tomorrow. And I don't care how the weather is actually being produced. I just want to know whether it rains or not. That's another scientific question. It's a prediction question. You might need to understand how climate and weather works and what the physical laws are in order to predict it, maybe. But in principle, you might also use methods that are so. For example, now they have using deep learning, so AI, let's say, AI methods to make really good weather predictions that could actually beat some of the classical weather predictions. And here you could say, well, I don't care that I don't understand what the AI is doing, what the algorithm is doing something, there's coming an output, but that output is quite good for my prediction.
Yeah.
So that's another question. And the methods that you should use for the different types of questions are different. The type of data that you might need. So it might also be that I really want to understand how weather works. I don't really care whether it rains tomorrow. What I do want to know is understand the physical laws that go together. And it's a different question.
It's such an interesting... I don't want to interrupt you because it's a great track we're going on, but maybe just to kind of put that as a footnote of the approach of going, I want to understand the physics of it versus I just want the algorithm to spit out something that I can use are so wildly different in like their initial approach, but the outcome is it feels like, are you process oriented where you want to understand the process, or are you just goal oriented? Because clearly you're right. I mean, being able to say whether or not it's going to rain tomorrow is extremely helpful. Whether any of us understand why we can do it, it's whatever. But we know whether or not it's going to rain with a high. It's just that split to me is insanely interesting as well. It's just I just wanted to note on it. It's wild thing. What's your take maybe on that? Like the difference between those. Do you have a personal preference?
Well, again, it depends on the question that I have. I would say as a scientist, I like the more mechanistic things, the more physically based. I want to understand things. At the same time, I'm a statistician, so I also want to say I want to know something about the world, and I can collect data. And then my basic scientific curiosities. How is the best way to extract that information that is in the data? So I have some data. Maybe I can also be part of deciding what the data could be collected, but it might also be that I only have access to this data. So, for example, I do work in climate science, and there you often need historic data, but. Bad luck, we cannot measure in the past, but we can maybe collect proxy data, or we have some data that was collected. It's not ideal, but it's what we have. Yeah. How then my question becomes, how is the best way to extract the information that is in the data? Because there might be information that is not clearly visible with the bare eye or with the bare mind, you could say. And you need more intelligent or more sophisticated methods in order to extract that information. And I think it's, for me, that is one of my scientific drivers, is how do we find the best ways to extract the information that is actually there? Because sometimes you can, you have the data that gives you some information about whatever you want to know about.
Yeah.
Then you can do something to get information out. So let's say you want to know the level of, you want to know the temperature in the day. And then you have a lot of temperature measurements. And then you can take the average. You take the average, you get one number. That is extracting information from the data.
Yeah.
And then the question comes, and then you say, okay, I have the data, so now I know what the data can tell me. Oh, no, there's more information in the data. Maybe you could also know something about what is the typical variability. So maybe the average is 10 degrees, but I can expect from 5 to 20 degrees, for example. So, there can be more information. Now, this was a very simple example, but of course, I'm working with quite more complicated stuff. But this thing about how, so it's actually a very mathematical question in that sense. How do we think about how to get that information out? How do we improve our ways of using the data that we already have? Or how can we design our collection of data such that it becomes most effective?
Yeah.
Often because data can be costly to collect.
Yeah.
If it's costly to collect, you don't want to collect just to see, and then that was not exactly what we needed. Now we go out again.
Next.
But of course, science is like that. So we do something that is suboptimal, and then we improve on it. Then we send it out in papers, or we do our thing. Others are reading. Other scientists are taking it up, and then we improve on it. We improve on our own methods. We improve on other people's methods. And science is going forward.
Yeah, constant iterative. We just keep looping and looping and looping.
Yeah, and that's the beauty of it. And you can sometimes make things. I mean, I've done many papers where it's like, "Whoa, this is the best I can do," and then two years pass, and I'm like, "Oh, but I can do also this," and then you improve on it and do it even better. And
naked through the street screaming "Eureka!"
Yeah. And then you say, okay, there's something to learn from the previous one, but I can do it even better. But if I hadn't put it out, just saying, okay, so let me just wait until I finish, then it doesn't. You have to put it out. You have to put yourself on a line, because of course you can also do errors, and you are on the line because other people go in and dig into what you're doing, and then maybe even discover that you did something wrong, or that you could do something better. It might not necessarily be wrong, but you might be able to improve on it. But that is the beauty. Yeah. That is the scientific process. That is the communication with other scientists, with the world, also with non-scientists. I mean, I think it's inherently human to have a scientific side. So I think all of us have a scientific side, even if we're not scientists, because it's basically human to be curious. Curiosity is let's say the trademark of science. That is to be curious. Children are born scientists.
Curiosity machines.
Yeah. And they go and explore and do and figure out stuff and learn that way. So I think all of us, not only scientists, but all of us would get something out of having a scientific approach to questions in life.
There's so many ways I want to go. It's crazy. It feels like, as you keep talking, there are like 10 different things that kind of pop to me all the time. I go, oh my God, I want to press all of the buttons here. Let me press the last button here. I have two ways that I want to go with this. I would love actually, let's go there, right? I think that's great. I think you you wrote an article, and I'll say this in Danish. But I'll translate it, obviously, for those. Yeah, there you go. The title was, hvis vi glemmer grundforskningen, gambler vi med fremtidens gennembrud. And in there you had a quote, and the quote is specifically what I want to touch on, because it relates to another point, and I'll translate that one. It's, alle nye erkendelser, der har affødt store gennembrud for menneskeheden, begyndte ikke med en business case, men med nysgerrighed. Which I think loosely translates to, all of the major breakthroughs for humanity didn't start with a business case, they started with genuine curiosity. Which I wholeheartedly agree with, which is also why I think I would love to get your take on the Institute for Advanced Study. To me, it seems ideal. And for those that don't know, the Institute for Advanced Study is founded in the 1930s in New Jersey, near Princeton. And like some of the first people are, Einstein, Gödel, Neumann, all of that stuff. Pretty not horribly, bad people to attract to an institution. But the idea is obviously, hey, we give you a position, no responsibilities, no nothing. Do exactly whatever you want. No, there's nothing we demand of you. Just go crazy. Which is a big contrast to, I guess, like standard academic life, especially as you progress, you get more administrative, burdens. You have to do committees and, peer review. There's so many things that take you away from like the core of what you fell in love with. Do you think the Institute for Advanced Study, do you think that's the approach? If we took Susanne, a couple of timelines of Susanne, different alternative universes of Susanne, which version do you think she contributes the most to science? Is it the Institute for Advanced Study, Susanne? Is it current Susanne? Is it extremely burdened by administrative stuff, Susanne?
That was...
You don't know.
I love administration. No, I don't.
It's been 95% of my time.
No, I mean, okay. So, obviously, if I talk,
okay,
if I talk from a personal point of view, I definitely thrive best in an environment where I am allowed to do whatever I want. So, but that doesn't mean that all scientists are working the best that way. So, I definitely think that it is extremely important. And I think we are losing a little bit that in the modern scientific world. I think it's extremely important that there is a playground for scientists. That there is somewhere where it's just the ideas of the scientists, because the scientists are the best to make up those ideas, and follow them, pursue that research. No doubt about that. What is so difficult for society to accept is that it doesn't have to be extremely expensive, but it does cost money. And some of that money will go to research that never seems to produce anything. And it might actually, because if we assign, I mean, I've done a lot of research, and some of it has ended out in articles and papers, and some of it has ended
reduced to the dustbin for all of eternity.
For the dustbin for eternity. So a lot of stuff does end up in my dustbin. Okay, so
but that's a necessity. That's
a necessity. I don't know how I would get anywhere without that. So for example, now I just submitted a paper. I'm very happy about the work there, and it has taken me. I would say it's taken me. I started more than 2 years ago, so it's taken me more than 2 years. Oof. It's not that I've worked continuously on that. I've also worked on other stuff, but I have worked really hard on it. And when I then look at it, it would not take me 2 years to do it. When you look at the paper, but it's because you cannot see all the things that didn't work. You don't see all the things I did that did not work out, or we did. I don't do this alone. This is so all these dead ends. But these dead ends, you have to go down these dead ends in order to find the right answers and to advance. So I think it's very, very important that we also have this playground money. In fact, I think here in Denmark, other countries do have it, but I think everyone at university, every researcher at university or at research institution should have, maybe not a lot, but some basic, what we call annuum, some basic money for doing some basic research that they want to do. And then you can have if you want bigger stuff or whatever, then you can have where you do this science applications, and then you get grants and stuff like that. But the problem is now that it's so competitive to get those grants, that means that you have some people that are very successful in getting grants and others that are less successful. And it's not just a question of whether they are, it's not a question necessarily of whether they are good at good researchers or not. It's basically about two things. Are they good at writing applications? That's one thing. But the other thing is also, are their research field something that is hot? And you can have research field that, as a first sight, it might not be the most popular or the most funky, as you said before, right now, but it's completely essential in the research ecosystem, because the ecosystem. So I think, okay, I mean something very specific with this word. I think diversity is extremely important. And here I talk about diversity in a very broad sense. We need diversity in methods. We need diversity, of course, also in the standard ones of gender and stuff like that. But what I'm talking about is in subjects, in ways, in personalities, in approaches, and we need that, because if we start defining that the excellent research is like this, and the excellent correct career trajectory is like this, and you should do this, and otherwise you are not competitive. We lose diversity, and in the moment we lose diversity, we lose ideas. We lose fertilization. We need in the ecosystem to have all those levels. And also because some research, and really now we're talking mathematics. I mean, this is about mathematics. There's lots of research in mathematics that really do not need a lot, just need good chalk and a blackboard and time and maybe a PhD student that you can discuss with, or and this thing can bring you really far. And then you have other research where you need really heavy experimental expensive stuff, or you need to go out and measure on Antarctica or whatever, and drill out ice cores from Greenland, and of course that is expensive. You need money for that. So there's so many different things here, but we are in this competitive modern world where we really want to be sure that the money is accounted for, that public money is not being wasted. And of course I agree with that. But the problem is that we have to understand how research ecosystems works. We also need to understand that without basic research, we do not have innovation. So innovation means that something gets out in patents and you might have a business case. But without basic research, we do not have innovation. And I know that I also understand, even if it's not what I do, I understand innovation is extremely important. And I think we, as scientists, we also have a responsibility for the society as such, to be a society where we can see innovation. And
absolutely.
So, but we need to understand, and I think it also was a little bit in the quote that you said from that Danish opinion piece that I wrote. We really need basic research for innovation. And if you look at, for example, the EU money, so the framework programs, etc., we can see that a lot of the innovation grants comes from people that first had basic research.
I love that. Yeah. I was about to say, it seems like the people that understand it best are the people who lived it. Like they know this is a process. Like that's just what it is. You cannot do it in any other way. There's a fun parallel in terms of not quite business, but there's a famous chip designer slash architect called Jim Keller, who worked at Apple and Tesla and AMD, and he's designed some of the best chips on the planet. And he would also always say, I can't remember the cycle, like every 5-6 years, you have to scratch everything and build the new chip completely from scratch. Okay. You have to do it. And then his point was, the first 2-3 years, you will probably, as you're building it, you will have a worse chip than the chip that you had prior, but that's part of the game. It's the only way you can supersede it. It's the only way you can improve it. Yeah. And then he said, like the great people that he worked with, like the Steve Jobs of they understood that that's just a game. Like you can't just improve the chip. You scratch it because there's so much you learn along the. Like your point of going, once you're at the end of it, you look back and go, it's interesting. I feel like I should maybe be able to do this better or faster or more efficient. But it's only because you're on the other side. Like as you stand at the beginning, you can't do it. It's just a nice parallel between what can seem like science and research can, to people who haven't done it, seem a bit abstract, but then you just go like, there's a physical chip, scratch everything and build it from scratch. That's how it's supposed to do
and I even think there's two things to this, because one thing is the mental process as a person yourself, that you need to do certain stuff in order for the mental process to be there. Yeah, that's one thing. But there's also this thing about when you do research, it's not all groundbreaking. If we only, I mean, it would be impossible to only do groundbreaking research. Sometimes you do a paradigm shift and everything, but then you have to do the hard work where you put the elbows in the table and start working and confirming and trying, and you need that also. You really need to understand that. You cannot always do disruptive stuff. I mean, you also need to settle down. And so this exactly with the chip. You do a new chip and you work on it. And sometimes you can do really important science that is, in a sense, incremental, but you are improving on what we already know. And then sometimes you do poof this way, and you do something completely different idea. When you do that idea can be really important. Yeah. But when you first put it out, it's only able to do so much. Then you have to do the the nitty-gritty work in order to improve, and then that becomes the standard. Maybe that becomes the boring we used to do, but that works up, and then maybe you can have another. But we just have to know we need it all. We should not ever try to make, let's say, a recipe for what is the perfect researcher, because that one doesn't exist. There exists the perfect ecosystem of us working together. Some works better alone, some works together, some has these ideas, some works in this case, some are good at disrupting and finding new ideas, but maybe do not have the brain structure to be, let's say, disciplined enough to then go and check the proofs, let's say. And then you need other people to do that, where you maybe need a technical knowledge that are really deep. So we need it all. And even within ourselves, I mean, I'm not always doing the same. Sometimes I'm doing more sometimes I'm sitting and just programming and trying out stuff, and then, what if I do this? And then I do a simulation, and then it looks like that, and then suddenly, I get an idea, and then I take out my paper or go to my blackboard and start writing, and then it's the theory, the things that prepares there, and then I have to go back, and then I just have to, all these things. So even within the same person, you have to try out all these different things.
Yeah, absolutely.
And we have to understand it as a society. We need this. We really need it, and we need it. We need it for many reasons. We need it for the richer societies. They actually do have science. I'm completely education and science, etc. But we also need it as human beings. I think.
Oh wow, that's a crazy angle, but that's a more. It's not controversial either. That's a more original take. That it isn't just from a societal standpoint, it's like the human, the individual.
We need this. We are curious as humans, and we need to develop that side of ourselves. If we want to be whole people, it's like if you want to be a whole person, You need to use yourself. I mean, might be better at something
Sure.
than others, but if you don't move, if you don't use your body, then something is missing. If you don't use your brain, if you don't use your creativity, if you don't use your emotions, we are whole people. If you don't use your curiosity and ability to see new patterns and structures and logic and stuff like that, and that is part of being human.
That's so interesting. Okay, let me dive into
Whole people.
I like that idea. The holistic. It's and it feels like that's the idea that reverberates throughout time of a lot of philosophy. I mean, the ancient Greeks are cool in that regard. That it is a holistic thing. It's everything. It's not. I think too, I can meet a lot of upper echelon business people or science people, and they seem to kind of neglect the physical thing just because the thing that they're doing is so important that they kind of forget the other parts. So I love the idea of the Greeks going, there's wrestling and you gotta, you have to really make sure that comes along. This is a weird pivot, and it's not necessarily that I want to stay here for too long, but I think it's interesting because we're here now. Anecdotally, I have a son who's 14 months, and it is crazy to watch him just go, everything is just crazy, and he's all over the place. But when I then also anecdotally look around and I meet people, sure, there's some people where you can sense there's like this deep curiosity, like they just have a, whoa, you can see the child is still there in a beautiful way. But for a lot of people, damn, that child is I don't know where it is. It's probably still in there, but I cannot find it. It seems like the spark has just been extinguished. And it seems like that's the case where if you were to go back to them as a child, they were all the same. Wow, wow, wow. And then something just, Any ideas? What do you hypothesize that is? What's your conjecture?
I mean, I wish you could keep it for the whole life. That's a difficult thing. First of all, we should allow ourselves to be that people and not. Okay, so I don't know what to say. One thing we could do is maybe not as much practice on ourselves, but practice on not inhibiting others, because if we all did that, that would maybe be easier for all of us. We have this tendency to judge, and this is not serious, and now you have to be. And if we judge less, maybe it's also more easy for everyone else, and that will also include ourselves to still hold fast to that that curiosity, that energy, and
that's an interesting take. I feel like a part of the problem, actually maybe it is that, it's when there's a child, they very quickly do something that to me, I'll just go, oh, you shouldn't do that. Like, don't touch that. But then I go, wait, why am I saying that? Why should he not touch the thing that's on the window? Like, it's completely innocent. And yet there's this, oh, don't do that. Yeah. And it seems like I'm inhibiting him completely. I'm stopping him from getting to explore. And you go, oh man, I can't do that. And whether or not that's a pass-on effect. And as he grows up, it's just a normal thing to say, you shouldn't do that. You don't really understand why. We just immediately do it. So the judgment part just becomes innate. Where if we don't judge, then he's free to kind of let that thing constantly roam and explore. Obviously, I mean, he shouldn't. I was about to say. I don't even mind.
You have to find some balance.
There's a fire, and I go, you kind of can. I don't know who am I to tell you.
Go explore.
Yeah,
no, maybe that's
check out the fire. Try to grill the hand and see if it's delicious or not. Yeah, that's an interesting part. Well, let me give you my super controversial take, and then you can react to it. I think a part of it is there's school. Is the idea is great, and I say it's controversial, but I also think it's unoriginal at the same time. There's something about you have to meet at this time, you have to leave at this time. If you don't like the subject, well, it is what it is. You sit there, and this process is so poisonous. I get why it's there, but like even today, if somebody told me you have to meet at 8, you have to go at 4, you just have to be here, and you have to do this, even if you don't think there's meaning in it, I would completely explode.
But sometimes this can also be good.
Oh.
Because sometimes structures can help you. Or, be in a structure and having kind of not completely, you can do whatever you want all the time. Sometimes this discipline can help you. So, okay, now I'm here at the university, and I'm also teaching students, and they have to go through 5 years of hard studies, and they really have to learn a lot. It cannot all be playful and pleasant and knowledge seeping in by osmosis. Sometimes it's just hard work, and you have to do it. And the fact of going through hard work can give you such good experiences afterwards. We also have to understand that there are certain parts of life that can hurt. It can hurt or be hard, and you have to go through it. And it's quite obvious that if you want to be an elite athlete or something in sports, it's quite clear. You have to do a lot. Yeah. You have to do sacrifices. You have to get up in the morning and do your exercises, do your training pass and all this. And everybody understands that. Why don't we understand it that there are other parts of life that also needs that? So if you really want to, so for example, we talked about this curiosity, and I said everybody is a scientist, but it's also hard work to be a scientist in that sense as a general human being, because it's so easy to be mentally lazy. So it is. You have to put energy into not being mentally lazy, and that also counts for me. I might seem okay. I'm very open to a lot of stuff, but then I have my blind ankles too, and then you're blind there, and then you get mentally lazy. And we just have to understand that if we really want to get somewhere, if we want the sweet, we have to work for it. There's no free lunch in the sense, and we have to do that in life. I think it's also an understanding in life. If you go through this hard work, then the reward is so much bigger. I'm dancing, and I'm still go dancing, and in that training there are lots of stuff that is that is hard and sweaty and stuff, but you have to go through. If you don't go, so the pleasure of feeling that in your body is enormous, and it's clearly this work you have to go through. And I think you also have to do it in other parts of life. We also have to teach our children. We cannot overprotect our children, because they have to learn that sometimes something hurts, and if they are not exposed to that, because we just protect them too much, they don't learn what they should learn during childhood, and then they get problems when they grow up. So I also think we have to understand that part. It's not to say you have to suffer in order to get the good thing. It's not that. It's not suffering. It's more like hard work can be a pleasure. It's not suffering. It's just hard work, making an effort. Yeah. It's not for free. Yeah. Do you understand the difference? Yeah. I don't want to go back to, if it doesn't hurt, it cannot be good. That's not what I want to. I just want to say that certain things cost work, and we have to put in the work, and the reward is just wonderful in the understanding. Yeah. So, for example, when I do research, often I get, I don't know if often, but sometimes I get these sudden revelation. It feels like a revelation. It can be on my bike, for example. It often happens on the bike, and I do have a theory why it happens on the bike. But it often happens on the bike. It suddenly, I can see the solution of some problem I've had. It could be, I mean, scientifically. And I've been working so hard. I've been sitting with my computer. I've been sitting with my paper doing calculations and stuff. And I just couldn't see how to solve this problem. And then I go on my bike and boom, there it is. But this revelation that comes so easily and like just for free, how did it come there? It only comes there because I did the preparation. Yeah. So it comes because I had all those endless hours of walking. I even sometimes just stand up and walk back and forth here in my office because I cannot find that solution or how to do it. Yeah. but that work is not. It prepares something inside you. It opens up for this possibility. And then just to go back, why do I think it happens on my bike and not while I'm sitting with this problem? It's because I have to let go. And when you're on the bike, you're concentrating on, you use your body, you are sweating, you have the traffic, your mind is forced to let go. And that is when you open up the possibility for this to enter. So often these things happens in the most unexpected moments.
I was about to say
cooking
that,
or
we're doing something completely unrelated to the task at hand. You completely
but you have
step
to
away.
You have to prepare yourself. If you haven't done the first work, it will not come.
I'm
to
just
you.
cooking, and then I go quantum mechanics. There we go.
Yeah.
I get it now. But it's an interesting. Yeah, it's like there's so many interesting nuances to what it means to learn, what it means to understand, what it means to get like insights where you just can like the epiphany that whoa, now I see it. Like the entire process of how do you get to that point is so odd because you're right. There's a version where it's truly hard work. You sit and you read and you think and you scratch and you like live in the problem, but you have to exit that universe and then just go, you're right on the bike and do whatever else. And then suddenly it's like the universe calls you back and goes, I got something for you. I got something. And it's, that dichotomy is so weird. And I think it's, there's this super funny, stupid idea of like, you have a mindset and then you have the grind set. This is this dumb idea of going, you have to work 70, 80 hours all the time because that's what you have to do to be successful. Where the idea of saying, yeah, sure, you have to put in the hours, but you have to take a break. And I don't know, actually it's kind of weird because I'm also trying to figure out like generally what is knowledge, what does it mean that I know, and like why is this thing working, right? Because it feels a little bit still black boxy to me. It feels like I don't understand why when I take a walk, I might digest it better and suddenly I get it and I come back and holy, whoa, there we go. I don't really understand what's happening, so it feels like I just have to trust. I just have to let go and trust. And I don't know, it's kind of weird. That I just, if I'm in a position going, I really have to get this to work, what am I going to do? And I go, so I got to take a walk. It feels counterintuitive. It feels like I should stay here more and I should do it, but it doesn't necessarily give me the output. I don't know. When did you have the realization that those stepping back, exiting the universe were beneficial, were conducive to whatever you were trying to achieve? Because it seems like a novel take. It's novel, but not quite novel. But it seems like it's.
But I've experienced it all the time. I've been working in science, so I mean, all the way back from when I was studying. I mean, just when you're studying, and it might be a completely trivial thing, but it's not trivial until if you understood it, and once you've understood it, it becomes trivial. Yeah. But when you are studying, just trying to digest and read. So it's not something like, okay, now I go for a walk because then I will understand. It's not like that. It's just studying, and at some point you have to take a break, and then and then suddenly you realize. So it's something that I've experienced at least my entire scientific life, including my study time. I remember many things that I suddenly understood, and it's curious because I even remember the most difficult year at university was definitely for the first year. Because it was just so difficult to understand anything, and I mean in high school I was just
crushing it.
I mean I never had to look more at once, and it was just easy. So I thought that it would just be more of the same.
How many years between you finishing high? Because I want to touch on this. I've kind of been saving it. And I want to go back to the probability in math, and we will do that. But maybe this is the best time to detour. Can you give me a quick walkthrough what happens up until you're like 40? Like, what the hell is...
okay, that was a long one.
Quick. Yeah, give me 40 quick years.
Okay, 40 quick years. So... after high school, so I did my high school, but then after high school, I did not want to do academic work or anything. So I wanted to be an actress.
Wow.
So I actually went to a theater school here in Copenhagen. So I took my acting school, and I was also dancing. So I've been dancing since I was a teenager, and that's the only thing that I keep from that. Then I actually went to Spain for 10 years.
Amazing.
And I did theater in Spain for 10 years. So touring a lot, working in different companies. I also had my own. I also directed some pieces. And then at some point, I had a child. I got divorced, and then I also felt like, do I want to do theater for the rest of my life? I feel I'm intellectually I'm missing something.
Interesting.
And then I decided for studying math, and I was always very, very good at math in high school and in primary school, and the problem is, it was not like now I want to study math in order to become something in math. It was more like a hobby. Ooh. Now I want to do. I want to use my brain in another way. My intellectual some intellectual challenges, and then the only place you can do math is at university. It's not like I want to do ceramics, so I can go on some ceramic thing. You don't do that with math. There's no so you just go to university. So I did that on a distance university, but it was not because I was deciding I wanted to finish. It was just because I wanted to do it.
That's awesome.
And then I was working at the same time. I was an actress, and after I've been studying like 2 years or something like that, 3 years. So the bachelor, basically, it was like, I'm pretty good at this. I like this. I like this.
That's crazy.
So maybe this is actually what I want to do. And that was when I started saying, and maybe I want actually to do research, and maybe I want to do a PhD. And then I was only like in 2 years. I already done the 3 years.
Of course.
So then I finished that, and then I decided I would try to go and do a PhD in Denmark. So I had been in Spain for 10 years, and I was at that point a single mother. So I also wanted to go back to be closer to my family. And he was 7 at that point.
Oh, wow.
So we came back to Denmark in 99, and then I started to apply for PhD positions. And then I ended up doing, that was, so that had happened 10 years from high school. So I started studying math. And then I started my PhD. I was, of course, older than the others, and I did my PhD at the biostatistics department here at University of Copenhagen. And that was quite good for me, because I was when I started, I was quite into pure math. I really liked the pure math, and I had not at all been interested in statistics or anything. But then I came to the biostatistics department to do my PhD, and I encountered data science or data analysis, you could say, how to approach a statistical problem, and that really caught me. So that kind of shaped my interest. This combination of the mathematical models, the understanding of the structure, together with the data to learn about the world from data using these mathematical models. And I ended up here at the Department of Mathematical Sciences, and where I have been. So I've been working a lot in basic statistical probabilistic work on mainly what we call stochastic processes. So something that evolves over time with some probability distribution in it. But then with applications in with mathematical models in biology mainly. And then in recent years, I've also worked a lot in climate science, in climate change and tipping points. So my main interest now is in ecology in the Arctic and in tipping points. But I've worked a lot in neuroscience also.
Jesus Christ.
With the mathematical models and single neuron models, and they're really there you really have a lot of variability and probability and stuff like that. But that's quite interesting. The brain, if you look at the single neurons and you look at the single elements inside your brain, it's extremely noisy.
Yeah.
And how come that you have this noisy machine coming out with such precise macro behavior?
What does it mean in this context that it's noisy? What is it that the neuron is receiving?
The neurons
tons
are
of.
Yes, if you measure on single neurons and you expose them to exactly the same stimuli, they will react very different from time to time. So if you repeat the trial, you'll get a completely different output. So the single neuron are just stochastically coming out with an output when you. So if you do, I've been working, for example, on visual processing.
So just for me to understand, if we kind of say we model this as a function, and then do you have the behavior of the neuron as kind of the output? If I take all of the same variables and I just keep looping, I just keep running the function with the same input, output changes. So it's like non-deterministic.
Yeah,
that's freaking weird.
But it has a distribution, it has a structure, etc. Okay. But when you put all these together, you have an overall. Let's say a very good functional output. So we are very much able to walk in a steady way, produce whatever we should. You throw me a ball and I will catch it. Well, maybe I will catch it, but more or less I will catch it. So all these things that are very noisy on the micro with an I, micro level, on the macro level becomes very ordered.
Interesting. Do you find that like fascinating in a positive sense? I'm sure it's fascinating in any capacity, but do you find that like uplifting and inspirational? Or do you find that disturbing?
No, I find it very uplifting, and I also actually now we are detouring completely. Anyway, so
we'll go back to the acting versus math. That's kind of the sure go.
So no, the fact is, you could think about why has evolution made our brains work in this way, and I am sure that there is an evolutionary advantage of working this way. And a way that I sometimes like to see it is, so imagine that you are crossing a street and a car is coming very fast to you. And you have to do something to avoid to be hit by the car. Mm. Where will you be in the best situation? When you stand and the car's coming towards you and you have to react, or if you're already on your bike or walking and you have to react? If you are in movement, it's much easier to react fast. So something is coming out and you have to react. If you're in a static state, it's much more difficult to react to perturbation from outside. So if you have to be reactive, and that goes from this let's say instantaneous level of something that's going to hit you to a more holistic level or long-term level of changes happening in your environment, and you have to adapt. You're a little plant, and now winter is coming or climate changes are coming, and you have to react to that. So these things of being in movement and this variability, this probability distribution is actually giving you a possibility of reacting better. So I do think evolution has designed us to do this because it's better for survival.
Okay.
For fitness.
I can't see the connection completely between. I'm trying in my head to try to go, like, if you look individual constituents, neurons can predict non-deterministically within some kind of distribution. You bunch a bunch of them together, like you group them into some kind of larger unit. Is that thing deterministic, or is it?
That become at least it becomes very stable.
I can't see that relation to the dynamic. I get the thing with if cars going completely like common sense wise. If I move, it's easier for me to just jump. Well, I need to speak into the mic. There you go. I jump. That makes sense, but I can't find the individual neurons to like collective unit and how that relates to the whether or not I'm static or in motion. I don't know if the question makes sense, but
okay, I don't know if I can say anything that makes sense here either, but just imagine that you are your brain is processing visual stimuli, so you are seeing a lot of stuff, and you have to make so say you're biking through the city, and you have to process a lot of information that's coming in, and you not only have to process a lot of information that's coming in, you also have to order it in importance so that you can ignore certain things but be aware of others. Because if you're aware of all of it, it will be very difficult to navigate. But you have to see the important things. And then you have a lot of neurons working in your brain in order to do all that processing, and they're doing a lot of different stuff. And if they were very deterministic, it might be very easy for you to maybe overlook something because it's just going for that thing, and maybe that's not the right thing. But you have this wildly stochastic thing that then orders what is the most important. I don't know. It's a little. I can see, it's a little fluffy what I'm saying, but anyway.
But I can see there's a version where I'm crossing the street and the car comes, but the motor neurons are completely deterministic, so they go, well, sucks to be you, fella, you're gonna get hit now. Where it's like it's too late. The sensory input, you're right, I didn't catch it in time or something. Where you're right, I can see the idea of having to need some kind of flexible mechanism to allow for
something like that.
This insane input. Yeah. Do you have any specific part of having studied the brain, and I guess that's also biological systems, do you have any part where you're like in complete awe at how insane it is? Is there one bit you remember where you had a thing of a reaction of what the, like, this is so crazy?
Yeah, but actually, now this is actually not for the brain, but I'm sure you have seen it, but it's a very simple thing, but then it's really
Those are usually
complex.
the best.
Yeah. So it's. Have you ever seen the I think it's called black sun. I don't know if it's called that in English. But when you have these huge amounts of birds, it could also be fish in the water.
Yeah.
But you have these birds that are going together.
Yeah.
So it's like this black cloud, and then suddenly they all change, boom, and then they go around and they make these weird shapes and they go together. Actually, these can be made with quite simple mathematical models, where you have all the birds or fish are single units.
Yeah.
And you do simulations where your model, it might have some randomness, but each unit is only sensing its neighbor. It knows nothing else than about its neighbor. And then when you simulate this huge network, they go wah, 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 and all together. And I remember when I first encountered these models, they were so cool. They were so cool. And also this fact of understanding that the math is so simple, and you can do it in such simple models, and then you have these structures. And I mean, that of course also could happen in the brain, I guess, if where you have certain. I don't know. Maybe I should not speculate too much about that. But you could also see it in traffic jams, for example. So a single car cannot make a traffic jam. You need the whole community of cars in order to have a traffic jam. But this understanding of these structures of what is actually happening there, I think it's really, really cool.
It's a completely insane. I was about to do.
And another thing. Now when we talk about the brain, one thing that I really for me was I mean, now it becomes trivial, of course, but because now I understand it more and have seen it. So, but I remember the experience of really, that is that you have these, it's called stochastic resonance, but you have effects where you have a deterministic model, and that deterministic model can actually not reveal the information that is underlying it. Okay, it becomes a little cryptic now. Then you add noise to it, so randomness. Poof, the pattern appears. So that means that if you have a system that is noisy, you get more information out than you have without noise. Okay?
Not okay.
And it's called,
Not okay.
But I can. The simplest example that was also historically kind of the first example, but that is quite easy to understand in a certain sense. So imagine that you, with your brain, want to understand. It could be, for example, a sound, and that sound is periodic. Bop, 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 something like that.
Sure.
So you have this periodic sound that your brain wants to capture, but it's very low. So it's very far away, so you nearly cannot hear it. So say there's a certain threshold, and if the sound is below this threshold, your ear cannot capture it. You simply don't hear it. Now say you have this oscillatory, so periodic sound, but it's below the threshold. You don't hear it.
Sure.
Okay. I don't hear it. It's deterministic, but it's below the threshold. Now I pour out some noise on it. So now instead of being completely periodic, it's a random process. Okay? But it still follows, of course, this structure, but it's random. Now you have the threshold. Now I have this. This is the deterministic. Now I put the noise. I hear it. I hear it. Okay, this didn't come. I hear it. So now I hear bop, bop. Missed that one. Bop. And I hear it because of the noise.
Okay, but in this case, I have to understand, like, what is noise in this case? Is noise an amplification of the volume? Is noise...
It's saying that it's not exactly what it was, but there's some randomness above. So sometimes it's lower, sometimes it's higher, but there's randomness around it. So instead of being the exact signal, it's something around that signal that is random.
Oh, that's crazy, huh? Okay, so instead of having the perfect pattern repeat itself, noise changes almost not the behavior. It
makes you able to detect it. And you not only detect that there is something there, it's not like sometimes it crosses the threshold for you to hear it, but it does it also in this, let's say, the same period. So you will actually recognize the structure below. Because if it is low, even if there is noise, you don't hear it. But when it's up, the noise does that it crosses the threshold.
Yep.
And that, so the stochastic resonance actually means that there is an optimal level of the noise such that you capture most. So you can imagine that you're going with a little bit, and that little bit is not enough for it to cross. So you need it to be bigger. A little bigger, and it crosses. But now you make it very big. Just see this. And now you hear it all the time, but you don't get that it's periodic. So there is an optimal level of noise where you best recognize the deterministic structure below.
Okay, wow, this is...
And there are lots of examples of that and much more complicated examples, but this is kind of the easiest one to kind of understand.
Yeah. Interesting. Yeah. The noise, is that part of the thing itself that we're looking at, the oscillating wave here?
Yeah, that's part of it.
So the noise is part of the thing. I can't remove the noise.
No.
Interesting. So it's simply part of the
thing.
So
it's like saying, if the system inherently has this noise...
Interesting.
Then it actually makes it easier to detect. And that you could also think about that if you have a signal that your brain internally is sending to you inside, if it puts noise on it, you might actually be better at detecting it.
Yeah. Wow, that's completely, man.
So that could be another reason for having noise in the brain, for example.
That's so weird, huh? Yeah, I don't know what to make of that. I have so many questions on it. Yeah, how generalizable would this be? Like, does that mean that, I should seek out noise? The question here isn't necessarily to minimize and remove noise. It's noise is, I say in this case, is a good thing, but it's like...
Yeah, noise can be good. That's one of the things that's why I like random processes.
How do we distinguish noise from the phenomena itself? Because if we say that the oscillating wave and the noise are part of the same thing, how do I determine that one is noise? How do I categorically say this is noise? This is the pattern?
So then you're again back in some kind of definitions, because here it's just because I call this the deterministic part, and then these on top I call the noise. But of course, the thing is just what it is.
Yeah.
I just call it something, which means I put a model on top of it.
Yes.
So and that is just for us to understand. So that's again this pragmatic thing. We formulate a model, and then that model is the one that helps us understand the underlying process or concept or whatever it is. So the things is just what it is.
Yes.
And I could make a model that it's just constant. And then the noise is a weird noise that not only just wiggles around, but also does this. So you see, you can have different models. And you have this, I'm sure you know it, this famous quote of all models are wrong, but some are useful. So it's just a question of finding a model that helps you understand better whatever it is you want to understand. And for the same thing, you might have different models that are better at answering different questions. So one of the standard examples also is, say you look at the world, you look at whole Copenhagen. Then you can have a map of Copenhagen. And that map can be more or less precise. It can be more larger or smaller. If you want it really, really precise, such that it contains every information about Copenhagen, it is Copenhagen. That is the map, okay? It's not really useful because it does not summarize anything, and you just have this huge thing. So you want to summarize it. Okay, so I have a smaller map. If I want to go by car, I would like a map that has very good pictures of very good illustrations of the roads and whether they are one way or the other. If I want to go to the cinema, I want a map that tells me where the cinemas are. If I want to take a walk in a park, I don't want the necessarily. I do want to know where the roads are with their cars, but I also want to know where. So all these things. Depending what is my question? What model do I need?
I love that.
And then I have different models for different questions. And different, not only more or less detailed, but different types.
Yeah, I love that. Okay, that's a fantastic way to answer that. There's the thing in it of itself, but which model we want to use, however we want to understand it, depends completely on what it is that we want to understand about it. Because you're right, in that case, there are 50 different models. I love the map of Copenhagen. Literally means I'm imagining putting down a piece of paper that shows the entirety of Copenhagen and go, there you go. And wow, that's great.
That's very, very precise.
It's super
Everything
precise.
is correct.
Great
completely useless.
Yeah, completely. I go, where am I
a
right
model
now?
always summarizes, so it's always wrong.
Yeah. That's so good. I love that. That's so funny. Even maybe actually let me go to, oh man, I love that we're going to things that I did not plan, but here we are. If I want to understand something, there's a instinct that came to me. It was like, that's a weird instinct that I have, where it's like, I go, is this, what field does this question belong in? Which isn't a bad heuristic, but I end up saying, I have to make a sharp distinction between, is it this or is it that? I go, does this belong to linguistics? Does this belong to, this field or this field or this field? And it seems as if I'm almost, it's not a bad thing to look at the thing itself through different lenses, but the thing is just what it is. It's not only linguistics or not only this. And yet my mind goes, well, if it's linguistic, then this is what it is. Like this has to be what the thing is. It's like, instead of just looking at it, which might be a combination of everything, it might underpin all of these different things. I say, oh, it has to be this thing. That's a weird approach. And so I started to question, what is it that makes me do this? And an obvious thing that I started to question was language itself, because I'm using words to describe this. And seeing, as you know, Spanish, we have to go back to the entire actress math thing. It's so crazy. But I want to go with the Spanish thing. There's a famous hypothesis / theory in linguistics, which is called the Sapir-Whorf hypothesis. The idea is there's a strong and a weak version of it. I spoke about this with in the first episode with Martin Hilpert, who's a cognitive linguist, and he's amazing. But the strong and the weak version is simply how much of thought is controlled by language. So how much of your ability to think about things is controlled by literally the words you have at your disposal. And so the strong version is like 1984 with Orwell Newspeak. If I remove every word that has anything to do with revolution, did I, put myself on top forever? Because now you can't do anything. Like I just removed the bricks away, the playthings. Or maybe it's a weaker thing. And my idea was, because I speak a bit of Spanish, and when somebody said to me something like, tienes sueño, tienes hambre, I was like, what the hell are you talking about? That's weird. You can't use that verb, or you can't. I was like, it's weird. You can't do that. And the obvious thing here is, for translation, it's like using the, do you have sleep, which is weird. It's like a possession
Do you have years?
Yeah, do you
for
have
your age?
Yeah, ¿cuántos años tienes? You're right. It's weird. You can't say it like that. But then I thought, that's crazy that they use different verbs to describe what we use. And I think even in Danish, I guess it's the same word. We just use the, ja for most things, I guess, not everything. And then I thought, I wonder if that has an impact. Does my relationship with sleep or years or hunger, does that change because I use a completely different verb? The idea of saying I have something feels very transitory. Like I have it and I give it away. But if I say I am sleepy, it could almost seep into like who I am as not an identity thing, but it's, I don't know. Does the idea make sense of like how much is language? Yeah. What's your take? Just weird to go into a little bit of language here.
Completely different.
Completely. Yeah, but seeing as you speak Spanish, I thought it's super unique angle you have.
I think it matters a lot, and actually, I think words matters a lot, and I also think that the way you can express things matters. I don't know very different languages. So I know Danish, English, and Spanish. So they are kind of the same.
Sure, there are a lot of similarities.
Yeah, there are a lot of similarities. But definitely it does make a difference. And if you have a word for something, and I also think it counts for mathematics. So certain things is if you get a new idea and get a new concept and a new whatever, and introduce that, will be very difficult for people to understand until they get used to it, and then you start being able to understand it once it kind of seeps into your being. That word. So definitely, I think one thing that I don't know if it's related to this, but I realized, or actually some people told me, then when I spoke Spanish compared to when I speak Danish,
your personality seems different.
Yes, my voice is a deeper voice in Spanish than it is in. So I spoke more like this in Danish and more like this in Spanish.
Whoa!
And I had no idea, but people could hear it. So it's simply my voice gets deeper in Spanish than in Danish in general. Crazy. When I relax and don't think about it.
Crazy.
And whether I would say that I have a different personality in one language than the other, but it definitely makes a difference.
Interesting.
It makes a difference, yeah.
Interesting. Yeah, that's very it's and you're right, this idea of kind of defining words is also a bit strange. It's weird how much I take for granted. And I don't even take it for granted. It's weird how much I run with an assumption that whatever I say, you must understand the same way. Like it's strange how much all of my communication rests on an idea that whatever I have in my head, surely I will teleport it into your head as well.
I guess we all have experienced a situation where we say something that is quite clear for us. This is what we want to say. And then when it comes back, we realize that the other person understood something completely different. It's a very human thing, I think.
Yeah. But I guess that's why does math provide some salvation there, even physics to some extent, with the very operational definitions of, when we speak of velocity, we freaking know what velocity means here. Do you feel it's easier to communicate with math when you're speaking to a colleague about something? Do you feel like it's easier?
Yeah, at least I think that math is a completely different way of communication than language is. I am actually also a language person. I love language. And I also like writing and I like reading. But
it seems like you're just deeply curious about everything, huh?
No,
it feels like there's
not
no
everything.
I'll
Not
just
everything.
do whatever.
I'm
Do you mime? Yeah, it's great.
Not everything. There are things that bores me. But anyway, but I think it's important to understand, and I think it's also very important that we think about that in our primary schools. That the language of mathematics is very different from the language of language. And what I mean by that, it's a different way of processing, approaching, understanding, and in that sense, when we teach mathematics, there's been a little. Sometimes I have the feeling that people think that it's since mathematics is difficult to understand for many people, or it's for all of us, so mathematics can be difficult. We should teach it in a way such that one can relate. So let's teach it as though it was social sciences or something like that. No, that is not the way, because it's a different language, and we have to do it in the language of how mathematics is. So we are not doing a favor to anyone teaching mathematics as though it was social science. In mathematics, there is a correct and a non-correct, and there's a logic, and there is a series of arguments. There's a lot of creativity also, because you can see solution in a different way, and all this. Lots of mathematics. We could talk a long time about that. But I think it's very important to realize that it's a different language, and we have to teach it in the spirit of the language. And for my own sake, I like to think in a mathematical way. But so one thing, when you go when you learn about teaching, then sometimes if it's not for mathematics as such, I have heard teachers say it's very important that you don't put equations, because if you put equations, you put people off, and then they don't understand. Well, first of all, good luck with teaching mathematics without putting equations. That's one thing. But another thing is, it's like when I read something in a book, so say it can be a scientific book or a paper or something like that, and they are so obsessed by doing this in language and not putting equations such that everybody understands. I read it and I'm like, couldn't you just put that equation so I know what you're talking about? Because it's like, it could be this, it could be that. First of all, why do I have to read half a page if I could just have an equation? Second, I read that half page and I'm still in doubt of whether it's exactly this or that. Just be precise and put the equation. Put it, because that's how I understand.
Is this a thing that actually happens? I haven't kept up with how math is taught or whatever.
No, not here in university. We are teaching mathematics as mathematics, and I don't know enough about primary school how they do it there. I just remember now my son is very grown up, but I remember when he was at school, he was in first class, so he was 7.
Yeah,
and he comes back with a math exercise. And I have studied math, and I'm like, I don't understand. I wanted to help them. I could not solve it. What are they trying to get it? So there was this exercise that put the number in this square. And I'm like,
what the hell does that mean?
What number? Where do I get the number from? What? I don't know what the exercise is. And I sent him back to ask the teacher, and the teacher tells him, and he comes back, no, we just have to pick a number and put it. Like,
what?
Okay, so 7 would be right, and 5 would be right. You just have to pick a number. And I remember I was like, what? I'm not trying to judge in any way, because maybe there's more to this, but It was just like this thing of, that is not mathematics. It's not like go with some logic and find some. It's not like, pick a number, write it. Okay, now I did my math exercise.
Done. Mommy, look at this. Whoa.
Okay, so it's this way of thinking that you have to train, and sometimes I think that when you don't know, when you don't do it, you deprive the children from having a mathematical experience, and it's a mathematical experience. So for example, for example, if you prove something in math, it can be, you can have a beautiful proof and you can have a boring proof, or you can have a technical proof that is not beautiful. And how do you define beauty in math? How do you define whether a proof is beautiful or not? And I think for most proofs, if you ask a mathematician, different mathematicians, they would agree whether this is a beautiful proof or not. So what is it that does it? Since we know exactly whether it's not a beautiful proof or just a proof that does the job, but is not beautiful. And one way I like to think about it is a beautiful proof. Well, at least that is one type of beautiful proof. A beautiful proof is a proof that gives you an insight into the problem and kind of gives you a sudden, this is how it is to be looked upon. When you get this sudden insight from the way, that is a beautiful proof. It's like, whoa, that was elegant. And then you sometimes just have to do all the work, all the technical stuff, and it's not really beautiful, but it just does the work and you want to prove it. So this experience where you suddenly get a new view of the problem, where you suddenly understand something. It's like, boing, and then you understand. That is the beauty, and that is the mathematical experience that we should give all our children.
Yeah, that's amazing. That's really, really amazing. What is because I guess you're right, with the natural language thing, now we're just kind of stripping away the mathematical notation and we're making everything very ambiguous. And, there are many different ways you can understand something. One of the issues I had with learning math was, so I came into math much later. And I came into it after I know a bunch of other things. And I mentioned this example as well with Kevin Buzzard last time, but it was, if I needed to learn about whatever depreciation is, I can just go, cool, what problem are we solving? You buy a car, there's a long life, there's an asset, it loses a little bit of value. Great, I know the problem, depreciation just comes obvious. And there are many different ways I can implement depreciation. It's like I can even play with the solution. But then I get into math and it's like, okay, square root of 2 is irrational. Okay, why? And I can even go through the proof and go, wow, that's crazy. But I still have a thing of going, oh, that's weird. Like, why? Like, why? And it feels like it's just what it is. The axioms tell you that's just what it is. And it feels so different in terms of how I need to think about things. Like, it really feels like there's mathematical thinking, and then there's all this other stuff, which is great. And it's how do you cross that threshold? I don't know if it's that crossing of the threshold that makes math fundamentally just different from everything else, and then difficult because if you don't know that you have to make that switch, if you don't know that's the lens you have to apply to look at things, then it's as if you're just trying to go, I don't understand why this is the case, so I don't understand what the problem is. I can't figure out how to do this because just even understanding the core of why this is the way it is difficult. I don't know if the question makes sense. It's weirdly phrased by me, but
I'm not quite sure what the question is. But actually, now you mentioned square root of 2, and that's a beautiful example because it has so many proofs, many different proofs, and each of these proofs gives you a different insight to why that is so. So I actually think that exactly understanding the proof is helping you to understand also the problem. But of course it is weird whether something is irrational or not. But it gives you an insight. But sometimes you just have to get used to it. Used to it, and when you're worked enough with it, it kind of becomes natural, and then you understand it better. I don't know if I'm answering what I'm not quite sure what you're asking.
Yeah, but my question was a bit oddly phrased. And let me try to take another stab. trying to formulating the question. Maybe it is, if I need to, again, if we go back to the finance depreciation thing, I can always understand what the problem is. Like, what motivates this thing? Like, there's a real physical need of going, how do we financially represent whatever this car is worth after 5 years or whatever? It's pretty easy for me to do, great, that's it. I don't need to do anything else. But with math, it's as if I'll go, why is the Pythagorean theorem actually true? Like, why is it actually, why not, like, a squared plus b squared for the right triangle? It's almost exactly c squared, but it's c squared plus 0.001. Like, why is it exactly c? It's weird that it's like that. And then if I keep asking why, eventually I just get to Euclid's axioms, and then I can't cross past. It's just that's just what it is. You start here and then you build, but you can never go beyond this point. Maybe I guess it's the same thing that physics would have. I would go to the fundamental particles and go, but what's after this thing? And it goes, this is just where we start, and then you build from here.
You need your axioms and yeah. But I think you should just think about it in, again, maybe here I'm pragmatic. I'm not looking at the philosophical implications of all these. But of course, you need your axioms. So the beauty of math is, given my axioms, given certain things that I don't go beyond, say, I assume this, and that. Where can I go from there? And then you start building a whole world of logic implications step by step from these axioms. And I think that is one of the things that I find beautiful in math. And of course, you can always start with, okay, so what axioms should we have?
Yeah, absolutely.
But
maybe it's actually logical thinking. Maybe that's actually all I'm trying to get at. It's that distinction. Like with the depreciation, it's like, yeah, you can depreciate this way. Can I do that? Yeah, you can do that too. It's good. But like with logic, it's like, these are the moves. This is where you end up. And that's it. You cannot just go, what if I just say that square root of 2 sometimes is rational? It's like, no, it doesn't work because this is how it's being forced.
And in math, you have right and wrong.
Exactly.
It's not, you don't feel it. It's not.
You can kind of.
You could discuss where you want to go and what you want to look at and what problems you want to look at. But once you have your assumptions about the basic axioms, there's something is right or wrong. I mean, in that sense, so.
Yeah, it's kind of right. It's kind of right.
No. But that's different from statistics. So one thing is the mathematics, and then the statistics is a different thing. And actually, that makes it sometimes difficult for mathematicians to really go into the statistics, because in statistics you also have a kind of evaluation of whether it's rational to what you're doing or not. You don't necessarily have this is right or wrong. You can analyze it different ways, and you can infer different things, and you have so you have kind of the mathematical foundation on which you base your statistical models, of which you then infer stuff. But this fact that you also have to interpret, you don't always have a right and wrong in statistics. You do in mathematics.
Yep.
That makes it sometimes difficult for mathematics. I've experienced that with students. Sometimes the statistical arguments can sometimes be unpleasant for mathematicians, whereas other students that I've had from, let's say, medical doctors or dentists or whatever, they can follow it perfectly well, but might have huge problems with understanding the mathematics.
Yeah, of course.
Or the formulas and stuff like that. But this mental leap for understanding the statistics sometimes easier.
Yeah, that's interesting.
It's fun, yeah.
And I guess it feels like that. Maybe the mental leap is good. It feels like you're crossing a threshold. It's not like this gradient where you go, I just need to nudge a little bit, but it's basically the same. It feels like you have to.
No, it's a different. It's
make a switch.
Yeah, it's different.
Which is super interesting. Who becomes a statistician now? Because
you're
Me? Yeah. Okay. But I guess why? That's actually interesting. Why you would choose statistics, especially coming from somebody who's coming from pure math. Where you write everything is perfect and like there's the, it's...
No, but statistics needs the math. Statistics are based on the math. You cannot do statistics without math. And here in Denmark, we have a very strong tradition for educating statisticians very strongly in mathematics. It's not like that in all countries.
Oh, wow.
So sometimes some other countries have mathematical statistics, which is very mathematical and probabilistic, and then you have the applied statistics, where you might actually not really understand the math behind. But here in Denmark, we have this long tradition of a very strong mathematical education of our statisticians. So we are educating the statisticians here at math, and they are following the bachelor together with the mathematicians, and they have a lot of pure math subjects.
But I guess my question...
And I think that is very good, because the understanding the understanding that you get by thinking as a mathematician is really, really good.
Yeah,
and it's really, really necessary for the deeper understanding of what you're doing in statistics, and also for seeing the problems that can come up when you do data analysis. Where can the wrong conclusions come from, or your the errors that you can make in your inference? And that if you have this mathematical background, it's much easier to point your finger at these places where you can commit errors and do very wrong conclusions. So in that sense, the mathematical training is extremely important for a statistician.
Do you feel with math, this is again a very abstract question, do you think it gives you something, it gives something to the individual that some of the other fields, whatever sciences that you want to look into, do you think that it gives you something unique to the individual?
Definitely. I mean, many fields give you something unique in a certain sense, but mathematics is kind of a strange animal. So and some places it is called natural sciences, and some places it's called social sciences. It's actually different places, they do it differently, and math departments are not always here. We are at the natural sciences.
Whoever calls math social science, that's all right. If that's a thing, that's crazy. That's
but the thing is that the so if you look at physics use a lot of math, of course, and biology also does, but physics uses math for understanding anything. But kind of physics, you really want to understand something about how the real world is working and trying to infer all this. But math is a world in itself. You can create a whole world in math that does not necessarily have something to do with what you see outside. You just do your axioms and start to build your world on that. It's extremely useful, and our world would not work without all the mathematical understanding that we have. And it's for me, it's so curious when people ask, but what do you use math for? It's like, what do you not use math for?
Freaking everything, dude.
Everything. Yeah. So it's like, what? It's so easy to see where you. I mean, math is one of the places where one of the subjects that you really can see you use it all the time and in all kind of different fields. And I mean, maybe you're not very good at it, and you have other people to do it for you. So, for example, that when you pay in a supermarket, there's they just the machinery, you're doing the math for you. But the math in a certain sense is like philosophy, and it's not random that historically philosophers and mathematicians were the same.
I was about to say that's one thing I would love to get your take on, because you're right. Descartes, Leibniz, Russell. I mean, some of the greatest mathematicians ever also double as being, the greatest philosophers ever.
Yeah, so math is quite connected to that in that sense, that you build up your world of logic. So you have some basis that you start on, and then you start building up your logical world on that. But the beauty is then also that often when many constructions of math that has been completely just for the pleasure of it, for the theoretical pleasure of it, turns out to have an application later on. Yeah. But I'm sure you all have a lot of examples of that. But that is very beautiful.
That's a crazy thing. Do you think it's because, actually, let's go to the Platonic realm thing. I think that's always fun to discuss whether or not you think it's real or not. Because there is something weird about the completely abstract math, pure math, somebody develops because there's like, this is a fun tangent, let me go on, it doesn't have anything to do with anything else. And then we go, whoa, this is unbelievable. Look how great it fits to this. Whether or not this Platonic realm, this mathematical realm, like it's a genuine thing that like these structures really do exist in some odd way. And if we can find something mathematically, there might be a counterpart in reality. We just haven't found it yet, but that doesn't mean that it cannot be mapped.
Well, I'm sure you can make up something weird in math that has its own inner logic that would be very difficult to find in the real life.
That does not exist.
Yeah. It's not like if you can invent it, it will also exist. I don't think that.
This is something crazy. Oh. Do you think the Platonic realm is a real thing? Like, what's your take there?
I don't know.
Because it's what do you think? Maybe actually going back to the language part. Yeah, because it's. If we try to describe like what does natural language mean, and I asked the Martin Hilpert the question of like why does language exist, and there are many reasons, but it's largely a cooperative. We need to figure out how the hell do we survive, so we need a way to say there's a rock, there's a tree, there's a tiger. We have to. There are a lot of mechanisms built into that thing, but languages, we communicate about this. Physics, I guess, is the same, but just very specifically. But if we say that that math is a language, like what is the What is the thing that we are communicating about? What is math actually trying to? I don't know if the question makes sense.
But I don't think it has to have something to. I mean, in my work, it basically always communicate about something specific because I like to work in this interdisciplinary setting. So I collaborate with physicists and biologists and medical doctors, psychologists even. Oh, wow. But I think we don't need to have something. I mean, mathematics exists in its own right, and you can have the mathematics for itself. You don't need to have
imbue all these weird extra. You have to.
It's just math.
Yeah, I like that. There is a version sometimes when I'm contemplating these ideas where I go, is there a point where I'm like, it's what was it? It's like I think Wittgenstein has like a general critique of like philosophy insofar as like you're philosophizing for the sake of philosophizing. Like the point of philosophy is to stop philosophy. Like you're going in circles. It's completely pointless. So like the idea of going, oh, what if math 1, 2, 3, 4? Is it like, sure, but like the pragmatic angle is it doesn't actually matter because this is all of the stuff that it can do and what we can use it for and develop it. Okay, let me go back to the actress thing because I have 2 questions. You can decide how you want to answer these in order. One thing is just when I spoke to Kevin Buzzard, we spoke about going into math later in life, and he was pretty skeptical. He was like getting into like research level math in your 30s was a little bit of a haha, like how would you even begin to do that? Like that almost seems crazy. And we can unpack why, he would carry that claim. But the fact that, you are here is an insane, objection to that thing. And it really is crazy to me how you managed to do it, both in terms of, you could argue that you were always good at math. You always had some kind of confidence and some ability carried with you. But even then, the thing of going, when did you start picking up math as a hobby? How old were you? Ish?
29.
29. I must imagine there must have been a bit where you look around and go, okay, great. How many other 29, 30-year-olds are kind of picking up math from scratch? And you go, oh, crap, there's nobody here.
Yeah.
That there would have to be a version of, oh man, is it too late? Is it too much? Literally look at the mountain that I'm trying to cross here. No, it's let me go back to, actually, let's do that question first, because that feels a bit crazy, that it feels like you're trying to attempt some kind of ascent of a mountain that nobody else around you are trying to ascend in your position.
But I also think, so of course, there is something about, there's something correct in what he says in the sense that when you have a young brain, you can probably do things that is more difficult with an older brain. So it's like with the body. And so in that sense, maybe yes. But on the other hand, I think the experience that I had before I started math has been very important for how also my mathematical career has turned out. And I think that it is with me in many aspects and I would probably have done different research had I only done math my whole life. So in that sense, we're again back to we are whole people. I cannot complain. I've had a really nice career, even though I started so late. But I didn't start studying math saying, oh, I want to be a professor at a university and having this research career. I just started it. And it turned, I started it as a hobby. Amazing. And then later on, when you're an actor, when you're working in theater, you always go from job to job. So when I was offered my PhD position, which is 3 years in Denmark, it was the first time since I left high school where I supposedly knew what I was going to do the next 3 years. So I never done that before. It freaked me out. I was scared. I was like, how can I do this?
Like the commitment part of saying I'm locking up the next 3 years?
The thing of knowing exactly what... you don't know what you're going to do in a PhD, but the fact of having a position for 3 years...
That's hilarious, because that's such an inverse opinion that everybody else would be the inverse and
but
oh my God, uncertainty, no.
But for me, it was scary.
Interesting.
It was scary. Then I got used to it, and now I've been sitting in the same position for, I don't want to even say the years. But then, of course, the fact that I had other experiences, I think flavored what I've been doing, what I am doing, how I relate to collaborators, how I relate to students, how I relate to my own research, how I relate to science communication. Everything is colored by that. And it's not only colored by the fact that I did theater, it's also colored by the fact that I lived 10 years in Spain, that I had a completely different life. It's colored by all my different life situations and what I've been through and all this.
What are some of the benefits that are being carried from that? Because I would love to...
I think one thing that I think is a benefit, well, one obvious thing is that I think I was more mature when I did my PhD. I was more able to take responsible of my own study. I was really designing it myself, and I also designed the project myself and did everything myself and did all the mistakes myself. And good. I think I was probably more mature in facing trial and errors and feeling stupid and all this. It did not bother me to make stupid questions where I could see other PhD students would be very inhibited of the fact of being scared of doing a stupid questions, and you don't learn if you don't do stupid questions. But I also think on a higher level that the fact of being in contact with other parts of myself and also the creativity, because you cannot be a researcher without creativity. And I think I had another approach to creativity, not consciously. So it's something deeper down that I cannot really put word on, but I'm pretty sure that that these 15 years that I worked more professionally with theater and that type of creativity has had an effect of how I let myself be open to new ideas, of seeing new angles, or trying to approach the different problems. I don't know.
Such an interesting dichotomy. I don't think I've ever met, and I guess it's super uncommon, no? That your situation is generally uncommon among like researchers in academia, yeah?
Yeah.
That's crazy. Does that, yeah. I was about to say, how does that make you feel? Does that make you feel like Yeah, what's even the way to phrase this question? I guess it's to say, do you look at that and go, do you carry that with pride and go, this is a very cool part of me because it gives me an angle that nobody has? Or do you go, I'm missing 10 years or 15 years or whatever of like pure mathematical research that these other people have?
Both.
Ooh.
Both.
Interesting.
Definitely. Because sometimes, I mean, not so much anymore, but when I did my PhD in the beginning, sometimes I was thinking, why didn't I start earlier? Because why didn't I use my brain for blah, 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 blah. But I also did that with dancing because there was at some point I wanted really to be a professional dancer. And I've been dancing on stage, but never professionally.
Yeah.
And I started as a teenager, but then I kept it up and on and off. And you should start much earlier, but all this. And I was like, why didn't I start? Why didn't I? Now I can never have as high legs as I could have had if, all these things. So this is kind of something that I've maybe had as a kind of things that hurt a little bit, but not anymore. Not anymore. I'm just happy of having had. I mean, you are the whole conglomerate of whatever you have experienced through life, and I am that too. And I can certain things that others cannot, and there are certain things I cannot that others can, and we're all back to this diversity. We need so many different. The more perspectives we have, and the more different personalities we have, the better are the conditions for having a healthy research or science ecosystem. So it's not like I don't want to be embarrassed about what I have done, but it's not like I feel more proud. I mean, I feel proud of myself. It's not that, but it's just what it is. It's just my life's story.
Yeah, absolutely.
I mean, I was through a divorce. Who wants to be through a divorce? But then I think, but I got my son. I couldn't have a better son in life. And that son would be different had it been another man. So I'm happy. Yeah. You know what I mean? It's just the facts of life that shape you. It shapes you what you've been doing, what you encounter in life, and I'm happy where I am.
All right. Well, in that case, speaking on the factors of life here, because let's go down that road. I love that road. Any existential crises in your life?
Lots of them.
Oh my God.
When not?
Yeah. I mean,
no, of course.
2 hours ago.
No, of course. Since I didn't go a straight line, of course, I've had existential crises many times.
Do you recall any that were pivotal, that really changed you maybe as a person, the trajectory of your life, like very intensely? Do you remember any that hit you much harder than the others?
Yes, of course. I mean, I think the moment that I decided I want to study mathematics is one, and also the time, which was much later, where I decided that I wanted to do a PhD, and later when I decided I want to be a researcher, but also when I decided to have a child, when I decided to divorce, when I decided to move from Spain to Denmark. Many of these things.
Yeah,
so all these, some of them painful, some of them joyful, some of them. Yes. I think there's so many of these.
In that case, maybe it's interesting to go into, because you're right. You make a lot of, which I guess this is also one of the reasons why I feel like it's a. Yeah, you're a weird cocktail in a great way, in a great way. That's a very good.
I don't know. Should I say thank you? Should I say what?
That's kind of weird. Okay. Because it seems like most people, like even if we take like academics, they're good at, let's go with math still. They're good at math when they're a kid. They're good at math as they grow up. They're good at math later in life, and so their life is just a stream of math. Like there's not really any major forks in the road where they have to make these really difficult decisions and like really look at themselves and go, what do I actually want to? Everything is just kind of, it's still wildly impressive and they put in tons of work, but the path is still like very much within the same direction here. But yours seems to be, we're gonna like a lot of difficult decisions. So what I'm very curious about is what's guiding those decisions. How do you know that you want to do one versus the other?
Yeah, that's a very good question, because actually many times in my life, it's very difficult to really understand how these comes about, because many of the decisions that I have taken, I've never been in doubt. It's not like I've never known where I would go, but then when the decisions come, they might be difficult, but then it's like it pops up, what is the right decision? Not always, but many times. So, sometimes I have some friend coming out, I don't know what to do. I could do this, I could do that. What should I do? And, for years questioning themselves. And I'm always like, why was I not more in doubt? It's like it showed to me what I should do. And it was literally boom, boom.
Oh, is it so obvious that I just always go, yeah, of course.
Not always, but
wow.
But often, I mean, it's of course, sometimes they're very difficult decisions. It's not an easy thing to divorce, for example. Of course not.
The obviousness, is that a result of you go to your chalkboard and then you start doing a pros cons, or is it a feeling?
I never did this pros and cons. I always heard about it, and sometimes I tried to do it, but it was like, but this seems the correct thing to do. I don't know.
Interesting. So it's like feeling based. There's some kind of instinct that just goes.
Yeah, I wouldn't say feeling, more instinct, but I guess it's also because I was quite old before I saw kind of this is my goal to go for, and then I come to here, and then I go that direction. So like I said, when I started my PhD, it was like, whoa, 3 years when I'm gonna know what I want to do. So it's like it has just rolled in a certain sense. It has just rolled. But what I think my story is a good example of, and I'm not the only one in that sense, is that alternative career ways can be fruitful. And I think we have seen historically alternative career ways, but they become more and more difficult because we become more and more, it becomes more and more, I don't know if it becomes more competitive, but we have more and more kind of rules, schemes, how to evaluate, and then we're back to what we talked in the beginning. We get this idea of the ideal career way, which was actually what you just described now, as the ideal, as the excellence. Yeah. And if you don't do that, that's not, then you will never get a position. I actually have the suspicion that if I did my career now, I would have no chance to get into the university. I think I do very valuable research, but nobody would have discovered. I would never have had the chance, because if I would be judged by the measures that there's today that are quite square, it would probably be difficult. We are not very good now at allowing alternative career ways, career path into these things, and this is a problem. We're again back to diversity. People are different, and we need diversity in also in career path, in personalities, in subjects, and approaches, and all this. So, I mean, I got my professorship 15 years ago. So for 15 years, I've been sitting in the same position, and I guess I have, in all this time, known that this is what I gotta do until I retire. So because I'm so happy with my job, I really, really love what I'm doing. I can be angry with certain stuff, and I can be angry with with the system, with a lot of stuff. But I really, really love my job, even though there are things that frustrate me and all this. But apart from that, so I know I'm not gonna. I'm not going to change job.
That's so interesting.
Unless a car hits me or something like that. So.
Of course, life just goes. Gotcha. Okay. If I then take the big step back here and then ask what's the meaning behind anything? Because that's probably the. But it's a fun one, because it almost goes back to the thing. Am I just putting myself in complete agony by posing the question of what's the meaning, if potentially there is no meaning? What is meaning of your life than in the sense of going, why do you wake up? It's fun and it seems like you clearly enjoy it, but is the point of waking up, is it to go, I just want to make sure that I have a great day. I want to do stuff that's fun. And then I do that until, whenever the day comes, the bus hits me, but at least I got to do what I wanted until then. Is it to, like, how do you answer that question?
Poof. I don't know what to say. I don't know what to say.
Yeah, me neither. So I ask it, I hope you can.
I usually have plans for the day, but it's not like I'm trying to do. It's not like I have the recipe for how you design yourself a happy life, and I'm not always happy either.
Sure.
So there are, of course, lots of stuff there. I usually have plans. They often don't succeed because then something happens and something else, and I don't get to do what I planned, and I'm always behind, and I have too many things and stuff like that. But then again, it's better to have too much than too little. So I don't know. It's not like I plan for these things, but I'm usually quite content. No, I can be frustrated and angry and all this, of course. But it's not like I plan for having a specific attitude.
Today we're going to do.
No.
Yeah, the spectrum of the. But if the question is, why do you get out of bed? Like when you wake up today, like why do you decide to do it? And I guess let me put it in the. Actually, no. Before we go there, let me try to put a little bit of context here. And I think the context is maybe interesting. Mortality, death. Do you think about that?
Yes, I do. Yeah. I'm not that young anymore. So, of course, that pops up. And I've had cancer. So,
oh, wow.
So of course, these things comes to you. But it's not like something that, for some reason, I think it's a very genuine human condition that emotionally we feel immortal. I mean, we might understand intellectually, and intellectually I do understand. It's not like I have fear of death or anything, but I do know I'm going to die. But
I love that perspective. Freud had the thing of going, how's it possible for the soldiers to storm the beach in complete crossfire, knowing 95% probability, speaking probabilities, they're going to die? How the hell how do you do it? How do you get them to do it? And then his response was, it's because when they storm the beach, they don't think, oh no, I'm going to die. They think, sucks for this guy and this guy. But they themselves have I agree that there's an intellectual, sure, I pass away. But this guy's definitely not passing away. Like there's an immortality almost built into perception.
But I mean, as many people, I try to live healthy, and I try to do these things that I need to do to keep. It's not only a question of not dying; it's also a question of being well.
Sure. Like also, quality of life, as long as duration of life. But if the question comes to fearing death, the fact that Susanne disappears and there's obviously an afterlife thing that we can get into as well. Does something happen or not? But in this naive assumption, not even naive, in this assumption, whatever we take it to be, where life does stop, do you fear the fact that you're going to meet that end?
No.
That's crazy, huh? Maybe it is. Maybe it's crazy.
I don't
fear,
have
not.
I mean, when the time comes, the time comes, and I'm. I mean, I would be sad if it happens within the next 10 years, but
sure.
Let's say,
or
20 years maybe. But I mean, I lost my father just 2 years ago, and of course that is sad, but it was also time in a certain sense because he was not well anymore. And I mean, it's just what's happening. I would be. There was was the old Zen master, and he was asked to put something wise on the fireplace, on top of the fireplace for somebody that lived there. And then he put, father dies, you die, son dies.
Yeah.
And And the person was like, why? What are you putting? Putting dye. I said, this is the most happy thing that could happen, that they do in this order.
That's good. Yeah, that's good. That's good to say. Yeah, you're right. There was reminds me of somebody said, I don't know who it is. It's some random surgeon doctor, and somebody says, like, what's the worst thing? The worst thing is when you see that order go wrong. When you see a young child or young parent or whatever, it's the order is the disturbing thing. Do you think there's benefit in contemplating death often? Do you think? Because on one hand, it's a pretty crazy thing to sit and think about, but on the other hand, do you think there's anything?
I don't think it does anything to me. No, I think, of course, I would like to leave something that is valuable for somebody, and you continue living in the people that remember you, and I think that's as far as I want to go. I'm not religious, so, and it does not scare me. We're just a bunch of individuals. Just think about how many individuals has been on Earth. Do you want them to be somewhere out there, all the individuals? I'm not sure it makes sense to talk about individuals in afterlife.
Yeah.
I think it's a little self-centered and misunderstanding what being is. But anyway.
Yeah, it is weird how much it's ego-driven, and it seems to be to let go of the fear of death is to somehow, what people classically say, you have to dissolve the ego. It's just because you think that you are, like, this existence of you is so special and so unique that it has to persist forever, which is strange. But I think the question is so fun, specifically to people like you that have such a good existence. It's like, I get you're old and your body decays, or you're wildly depressed and everything is just bleak. I get that existence is so difficult that it feels like it's salvation. Death becomes salvation. When you walk around, I can't wait for the day to begin. It's like, oh man. Then it feels like the ultimate party crasher. It feels like, you go, this is the best time ever, but it has to end. And I guess there's and maybe the question does indeed go to, like, how should you, that thought, because it is there, it's always looming, should you take it into your heart and live with it and let it sit there, but it's a heavy, heavy thought? Or should you try to say, I'll just push it until the day comes, I'll push it?
Honestly, I think that if it comes in the right time and you're old enough, it will be an okay thought to, I've had a good life and now it's ending. One thing I do want to say is that I think life has become easier with age. I'm 61 now.
That's an interesting answer, yeah.
And I must say that in many senses, life is much easier now than it was 30 years ago. Mm-hmm. And when I was 50, it was much easier than... So I think when you get older and more experienced, and I think I have lived my part of experiences, it matters less what people think. And life as such just becomes easier. I can feel in my body. My back hurts when I get up in the morning, and then I have to start moving. And when I move enough, it stops hurting. And there are lots of stuff. I cannot do the same thing at dancing as I could just 10 years ago. But life is easier. Yeah, it's just.
Not a weird, but you're right. It's a fun push-pull thing. Some things, the body decays a bit, but you have...
I think I'm better at handling conflicts, controversies, problems, challenges. I'm just better at it. Yeah. Better at handling all these things. And that does just my life so much easier.
But let me give you just a wildly trivial question. I love going from, what's the point of anything and we're going to die, to what I'm about to ask you now. You seem to have a ton of energy. Now, I don't know if that's just here and now and in 30 minutes you're going to crash, but it seems like you have you got some batteries in you that have a lot of capacity. There's a lot of watts happening in there.
Okay.
Yeah, which I think is interesting because I think that the question of energy is kind of funny. Like, is it a genetic thing? Is it a lifestyle thing? And arguably it's going to be a combination. But I'm kind of curious, like, what does your day-to-day look like? Like, do you wake up, scroll Instagram for 2 hours, and then you grab a McDonald's and...
Yeah, well, that's a difficult question. No, I know I have a lot of energy, but not in the evening. I am a person that falls asleep in the evening. Don't ask me to be very active in the evening. Actually,
it's a very different experience if we do this in a couple of hours. It's a very different experience.
And then you would need to feed me because I go. Yeah. No, I don't know. I try to live in a way that is good for me. So I don't like to say I want to live in a healthy way, etc. But I do realize what's good for me and what is not good for me. I'm not a saint. I sometimes eat more chocolate than I should. Let me just say, and stuff like that. But at least I'm trying to do things that is good. Yeah. No, I do have a lot of batteries. It's true. I do have a lot of energy, and sometimes I get very tired. But I have no idea whether that's genetic or where it comes from, but it's a gift. It is a gift. It's also sometimes bad because I have the tendency to say yes to too many things. So I have too much to do, and then sometimes I cannot comply with what I promise. But anyway, that's just how life is.
Yeah.
I find a lot of stuff interesting, and it would be easier to be more monofocal. Yeah. Life would be easier, but and sometimes I'm trying to catch too many things and too many.
Juggle 14 things at the same time.
Yeah, juggling too many things. But anyway, that's just how life is.
So part of the game, it seems. No, because it does seem like, speaking to you, it seems almost genetic that you cannot engineer this. Like, you can't just lifestyle-wise engineer what you have. It feels like there's something in your brain or whatever the hell. I'm getting very esoteric here, but it feels like you just have a sixth gear. When I speak to you, you can reach into it and kind of grab it. It's
you can also find me very tired sometimes.
You can definitely put it back into first. I'm not saying that it's sixth all the way, but it seems like you have a gear that other people can't. If other people need to woof, they can get to fifth. But it feels like you naturally, maybe it's a weird thing that I'm stating, but it's just yeah. Even just prior to taping, I could just feel that there was a kick. There was yeah. Anyways, okay. As perhaps a last question here, because you've had such a crazy life, if you have a conversation with yourself at 15, 20, 30, 40, whatever, anything that stands out in particular where you go, this would be a fun thing that we would talk about. This would be a fun piece of advice I would give myself. And maybe a piece of advice that could extend to other people as well.
Yeah, definitely. I think that when I was younger, I was too occupied with what other people think. I was too self-conscious. You should not be self-conscious. I was too self-conscious. I was too occupied with... succeeding, fulfilling, and it's not good. You should not be too self-conscious. You should not be, and of course I've done a lot of mistakes that I would. But on the other hand, if you don't do these mistakes, how do you learn? But maybe an advice would be relax a little more. Relax a little more in all your thoughts and stuff like that. So. Try to empower yourself in the sense of standing on who you are. You might be weird or different, so that's how you are, and just be that. I mean, there are also people that I admire. Oh, I want to be like them. And then I think about, why would I want to be like them? They're different from me. I would not feel comfortable doing that. I can admire it, and I could want me to be like that, but I am not like that. So I have to be myself. I mean, for example, it's just a stupid thing, but when I give talks, present, I have a way of doing it. Then I see, and I like presenting, I like these giving talks. But then I see somebody who's brilliant. I think, whoa, that's a trick. I want to do that. And then I think, but I'm not that person. I'm not able to do that type of joke or that type of charm. I can just hope for me having another type of charm and being different in when I present in what they are. Of course, you should steal for whatever, whenever you have tricks of, and we all do that, and we should do that. That's part of the game. But you also have to understand who you are and just be fine with that. And there are just certain things that maybe the aspects of me that I would like to be different, but they are not. So this is what I have. This is who I am. So I'll do the best of that, and just use that. I think. So my advice to my younger self is relax.
Yeah, this is probably...
And there's also definitely certain things that I would not accept today that other people did to me. I mean, situations and stuff like that. There's definitely this I would not accept today, and I would not. I would just say no. I mean, and there are certain things. It took me a long time to be able to find my limits and find where I am and where I like to be. But maybe that is just something that comes with age, and that's also part of me thinking that it's easier to exist today than it was. I feel much better today. Mm-hmm. Life is much easier today, even though I have more complicated problems, more complicated challenges, more complicated work, many more things to do, much less time. I mean, all of these things. So objectively, if you look at it, it's more complicated. It's like when I said the first year of university was the most difficult one. There was not technically the most difficult one. Of course, fifth year is much more difficult than first year. But the approach, the understanding what it is to study, understanding what it is, all that became much easier.
Mm. It's an amazing series, a string of advice. I think almost all of it is pretty crazy. Even just the dichotomy of going, you don't want to make the mistakes, but the mistakes are kind of part of how you learn. So kind of splitting those, and yet there are still nuances you can take that with you in terms of how you make the mistakes, your approaches to them.
But time has also changed. Okay, I don't want to be. I mean, I think that many things has changed to the better. Also, maybe to the worse, but there are a lot of things that have changed to the better. Now it's easier to be a young woman today than it was when I was a young woman. There are still problems. There are still things we have to do. But there are certain things that we were exposed to that I think young women, at least here in Denmark, luckily enough, is less exposed to. And we still have a way to go. But I must say that, certain things that I should have not accepted when I was younger are also things that probably some young women or many young women would not accept today. But we accepted it back then because that was another time. But I hate that expression. It was another time, so it was okay, or what? So, but there are certain things. So certain things are getting more complicated. It's maybe more difficult to be in, but there are other things that are getting better, and hopefully it will continue that way to get better. But I hope that it will be easier to become a scientist today without fitting in to the image of a scientist.
Yeah, that's an interesting development. Yeah, and I like the idea because it seems like just with anything, this is why I think, okay, I don't want to go back and rehash anything, but it's like this why the Institute of Advanced Study is good, because I think it's good to have problems that are challenging and interesting and great, but they have to be like problems that make sense. Like the problem of going, oh, I have to write this grant, I have to spend tons. It's like, yes, it's a problem that has to be done. It's such a silly problem, but it's like in your case, it's even sillier. Like these stupid things that are stopping people from getting to do what they want. It's like it's stupid problems. They should not exist.
I use far too much time on writing applications that I could use in research.
But it is indeed that. It's like, let's use the brain juice for the problems that really move the needle and not the, administrative, whatever burdens of this is what one has to do. I think that was amazing. And I think I love just the last thing, the piece of advice of going, because this is something that I definitely had a lot growing up, which I think obviously probably most people do, which is you look at people you admire and you're inspired by, oh my God, I wish I could be like them. But that's not the point, because if they did the same thing to their heroes or whoever inspired them, they would not be whatever you're looking at anyways. They would be you look at comedy and how many different comedy styles are. If everybody looked at the same person, it would be weird. You have to
find your own.
You have to find your own. And whether that's a hey type of comedy or whether that's the load back and you can kind of figure out whatever the hell you can do. It's an amazing piece of advice that I think is it's very powerful and something that I have to be cognizant of often, because it's easy to look at somebody and go, wow, I want to beat that. And there are traits probably that I want to steal, but I'm not looking to be. To take that completely. Susanne, we've been speaking about 2.5 hours.
Okay.
God damn, I still have like 20 questions I would love to get into. It's crazy. Your background is unbelievable. You feel like such a powerhouse. It's really, I'm super thankful that you said yes to this, Susanne. This is incredibly fun. I would love to knock on your door sometime in the future and go, Susanne, can we do it again? Because I want to pick up on like 30 different things that I didn't get to do. But seriously, Susanne, thank you so much. This was
Thank
awesome.
you to you.
Awesome.
It was a pleasure.
Awesome. I appreciate that. Great. Woo.